My name is Flash Isaac, and I'm a teacher from the future. I shall be introducing matrices and determinants. Matrix is a number or letters arranged in a rectangular form and enclosed in a bracket or parenthesis. Now, this is a typical example of matrix. In this case, we have letters arranged in a rectangular form and enclosed in a bracket. Identity property, commutative property, associative property, distributive property, and closure property. If E star A is equals A star E is equals A, what property of binary operation is this? Now, E is identity. You operate a number with the identity, and at the end, you get the number. You operate a number with the identity, and at the end, you get the number. That is simply identity property. When you operate a number with the identity, you will get the number. And commutative property states that A star B is equals B star A, which means if A is 2 and B is 3, if you use A to operate B, you will get the same answer as if you use B to operate A. So any of the other, then you get the same thing. In mathematics generally, you notice that addition is commutative. If you are saying 2 plus 3, this is 5. If you are saying 3 plus 2, this is 5. So irrespective of the one that comes first, the answer remains the same. That is commutative property. And in binary operation, addition and multiplication are commutative. Subtraction is not commutative. Now look at matrices. Commutative property of matrices states that if you have two matrices, A plus B should be the same thing as B plus A. And addition of matrices is commutative. But multiplication of matrices is not commutative. If you have two matrices, A times B is not always equals B times A. How about associative properties? Associative properties of binary operations states that if you have A star B in bracket star C, it should give you the same thing as A star B star C. There was a question we solved where you have something star something star something, and I told you to solve something like this, first of all, deal with the bracket, then you get everything here, you use it to star the third number. So if you have A star B first, then you star C, this will give you the same thing as you solve B star C first, then you star it with A. If that gives you the same answer, then that is associative property. Also for matrices, the associative property of matrices states that A plus B plus C should give you A plus B plus C. For matrices and determinants, addition is associative. For matrices and determinants, multiplication is associative, but multiplication is not commutative for matrices. Meanwhile, for binary operation, multiplication is commutative, addition is also commutative. Now, distributive property of binary operation. If you have A star, then B star C in brackets, this should be the same thing as A star B first, then star B star C. Then closure property. If A is an element of P and B is an element of P, in conclusion, A operation B is an element of P, or A operation B will be an element of P. It is closed over another. When you are naming matrices, you name the row, you add by, and you name the column. This is a typical matrix. The values you see from here this way, they are referred to as the row. In this example, this is row 1, and the elements of row 1 are 2 and 4. This is row 2. The members of row 2 are 6 and 8. Then if you are looking from the top, you are looking at the columns. This is column 1 and this is column 2. The members of column 1 are 2 and 6. And the members of column 2 are 4 and 8, like this. To name the matrix, you first of all name the number of rows, you put by, then you name the number of columns. Look at here. Counting the number of rows, we have 1 row and we have another row. So this is 2 rows. Then you add by. Then columns, we have 1 column, another column. This is 2 column. This is 2 by 2 matrix. Or you say 2 like this. The times represents by. When a matrix has only 1 row, it is referred to as a row matrix. And when a matrix has only 1 column, it is referred to as a column matrix. If you have something like this, 2, 3, 4, this is a row matrix. Row. And looking at this matrix, it has just 1 row and it has 3 columns. 1, 2, 3. This is 1 by 3 matrix. But since it has just a row, it is a row matrix. If you are given a matrix like this, 2, 3, 4, this matrix has only 1 column. This is a column matrix. How many rows does it have? 3 rows. 1, 2, and 3. This is a 3 by 1 matrix or a column matrix. 3 by 3 matrix is matrices or a matrix where you have 3 rows and 3 columns. Matrix is singular. Matrices is plural. If you have 1, 2, 4, 3, 6, 5, 2, 1, 1, like this, this matrix has row 1, row 2, row 3. It has column 1, column 2, column 3. And to name the matrix, you write the rows first. 3 rows, then you say by. How many columns? Determinant 3. Topics. Matrices can be added and subtracted. Matrices can also be multiplied. Multiplication of matrices is not commutative. However, it is associative. And matrix multiplication is distributive over addition and subtraction. To add or subtract matrices, they must have the same number of rows and columns. 2 matrices can be added or subtracted if and only if. In mathematics, IFF stands for if and only if. So, they can be added or subtracted if and only if they have the same number of rows and columns. And how do you add or subtract matrices? You add the corresponding elements. If you have this matrix and you have this matrix, to add the 2 matrices, this A here is in the same position as 4. You say A plus 4, B is in the same position as minus 8. You say B plus minus 8. Then C plus 6 and D plus 7. You add the elements that are standing in similar position. The members of matrices are referred to as elements of the matrix. And for multiplication, 2 matrices can be multiplied together only when the number of columns in the first is equal to the number of rows in the second. The number of columns in the first matrix should be equal to the number of rows in the second. This is it. If you have a matrix like this, this is the number of rows and this is the number of columns. The number of columns in the first matrix should be equal to the number of rows in the second matrix. If you have, this has 2 columns, and if you have another matrix, 2, 4, 5, 6, 4, 1. This is a 2 by 2 matrix, while this is a 2 by 3 matrix. 2 by 2. You notice that the number of columns in this matrix, 2, is equals the number of rows in this matrix. This has 2 rows. Even if the number of columns is different from the number of rows in the first one, or the number of columns in the first matrix is different from the number of columns in the second matrix, provided that the number of columns in this first one is equal to the number of rows in the second one, then these matrices can be multiplied. And equal matrices are matrices that have corresponding elements to be the same. If you have matrix A, B, C, D, and you have another matrix 4, minus 8, 6, and 7, they can both be equal if A is equals 4 and B is equals minus 8. Then C is equals 6 and D is equals 7. And a matrix is said to be 0 or 0 matrix when all the elements are 0. Everything in the matrix are 0, 0, 0, 0, and 0. Then we have triangular matrix. A matrix is said to be triangular if all the elements that are not 0 in the matrix, they form a triangle. Look at this matrix. You have 0 here, you have 0 here, you have 0 here. Then you have other elements. If you remove the ones that are 0 like this, what do you form? You get something like this. So this is a triangular matrix. Now the first question before us is, if the matrix P is equals this and matrix Q is equals that, find 2P plus Q. This is scalar multiplication of matrices and also addition of matrices. We are looking for 2 times P, then we add it to Q. 2 times P is simply 2 times 5, 3, 2, 1. This is a 2 by 2 matrix. To multiply a matrix with a single number, if I give you a single number and I say use this single number to multiply a matrix, what you simply do is use the number to multiply the elements of the matrix one by one. To have 2 times 5, 10, then 2 times 3, 6, 2 times 2, 4, 2 times 1, 2. So 2P is therefore equals 10, 6, 4, and 2. Nothing more, nothing less. But that is not the final answer, and that is not what we are told to do. The question says, find 2P plus Q. This is now 2P, 10, 6, 4, and 2. Let's add Q to 2P. Meanwhile, Q is already 4, 2, 3, and 5. The matrices, they have the same number of rows and the same number of columns. Therefore, addition is possible. How do we add matrices? So, you add the corresponding elements. This guy and this guy, they are standing in similar position. This guy and this guy, they are in similar position. 6 and 2, they are in similar position. 4 and 3, they are in similar position. What is the position of 6? 6 is in row 1, column 2. The first row, the second column, that is the position of 6. 2 is also in the first row and second column. The ones that are similar, you add them. We therefore say 10 plus 4, 10 plus 4, 6 plus 2, 6 plus 2, 4 plus 3, 4 plus 3, 2 plus 5, 2 plus 5. So this will give you 10 plus 4 is 14, 6 plus 2, 6, 7 is 8, 4 plus 3 is 7, 2 plus 5 is also 7. So the answer is 14, 8, 7, 7. Let's see if there's any option like that. Looking at all the options, option A seems to be the correct option, and that is the correct option. Let's look at the next question. We are given two matrices, M and N, and we are asked to find 2M minus 3N. This is algebra of matrices. And don't forget, the first matrix is M, the second is N. They did not say M minus N, no. They said 2M minus 3N, which means the matrix M, multiply it by 2 to have something like this. 1, 3, 2, 4, 5, minus 1, minus 3, 2, 0. Minus 3N, multiply N by 3 to have 1, minus 2, 3, 4, minus 1, 5, 2, minus 3, minus 1. To multiply a matrix by a single number, irrespective of whether it is 3 by 3, 2 by 2, whatever, the same law applies. You use the single number to multiply each of the matrices. In this case, 2 times this guy will be 2 times 1, 2, 2 times 3, 6, 2 times 2, 4, 2 times 4, 8, 2 times 5, 10, 2 times minus 1, minus 2, 2 times minus 3, minus 6, 2 times 2, 4, 2 times 0 is 0, minus 3 times 1, 3, 3 times minus 2, minus 6, 3 times 3, 9, 3 times 4, 12, 3 times minus 1, minus 3, 3 times 5, 15, 3 times 2, 6, 3 times minus 3 is minus 9, and 3 times minus 1 is minus 3. From here, this is 2M and this is 3N. So the way we subtract matrices is also the way we add matrices. While adding the matrices earlier, we said add the corresponding element, meaning 2 and 3 here, they're in the same position, you add. 6 and minus 6 are in the same position, you add. That is how we also do for subtraction. You subtract the ones that are in similar position. Here, 2 and 3 are in the same position. This and this same position. And this is actually easy because you cannot add matrices when they are the same dimension. They must have the same rows and the same column, so that the one standing in similar position will be operated. For example, 0 here and minus 3 are in similar position. You subtract them. Now let's get back to business. 2 minus 3 is minus 1. 6 minus 6 is 12. Minus 6 is plus 6. So 6 minus 6 is 6 plus 6. That is 12. 4 minus 9 minus 5. 8 minus 12, that is minus 4. 10 minus 3, that is 13. Minus 2 minus 15, that is minus 17. Minus 6 minus 6, that is minus 12. 4 minus 9, that is 4 plus 9, 13. 0 minus 3, that is 0 plus 3, that is 3. So the matrix is therefore minus 1, 12, minus 5, minus 4, 13, minus 17, minus 12, 13, and 3. So ladies and gentlemen, this is the answer to this question. And this find the inverse of the matrix N is equals 2, 3, 1, 4. 2, 3, 1, 4. the inverse of the matrix. At the end of this question, you will understand two things: how to find the determinant of 2 by 2 matrices and how to find the inverse of 2 by 2 matrices. Before you look for the inverse of 2 by 2 matrices, the first thing you do is to find the determinant. How do you find determinants of 2 by 2 matrices? Look at this. If you are given 2 by 2 matrices and you are asked to look for like this, or determinant of n, simply use this guy to multiply this guy minus this guy times this guy. That is determinant of any 2 by 2 matrix. In this case, you say either 2 times 4 or 4 times 2. They are the same answer. Multiplication is commutative. 4 times 2 minus 1 times 3 or 3 times 1. This is 8 minus 3 and this is 5. The determinant of this matrix is 5. From the matrix, there is 2 here, 3 here, 1 here and 4 here. Do like this. The one that is here, take it down. The one that is down, take it up. So here becomes 4, here becomes 2. The one that is here, change the sign. The one that is here, change the sign. This becomes minus 3 and minus 1. Divide everything by the determinant. That is over 5. This is the same thing as 1 over 5, 4 minus 3 minus 1 and 2. This is the inverse of this matrix. That is how to find the inverse of any 2 by 2 matrix. You look for the determinant, then you switch. The one that is here, take it down. The one that is down, take it up. Then the ones that are here, change their signs. If they were positive, change to negative. If they are negative, change to positive. That is it. Let's see another example. Even this matrix A, this is a 2 by 2 matrix. If you are told to find A raised to the power of minus 1 or 1 over A or A inverse, you simply, first of all, find the determinant of A. How do you do that? You say this times this minus this times this. And what is that? 4 times 2 minus 2 times minus 2. That would be 8 minus 2 times minus 2. That is plus 4. So 8 minus 4. This will give you 4. So A like this is equals 4. That is determinant. After looking for the determinant, you find the adjoint of the matrix. How do you do that? What is here, you bring it down. What is down, you take it up. Then you change the sign of this guy to give you adjoint 4, 2, 2, 2. This is minus, you change it to plus. This is minus, you change it to plus. But for these other guys, don't change the sign, just invert. What next? You divide by the determinant to have 1 over 4 because the determinant is 4. This is your inverse, A inverse. In some questions, JAMB will do the division. Instead of doing something like this, they will actually divide. How do you do that? This is the same thing as 4, 2, 2, 2 over 4. Because we are dividing by the determinant. Dividing each of the elements by 4 by saying 4 over 4, 2 over 4, 2 over 4, 2 over 4. This is the same thing as 4 divided by 4 is 1, 2 over 4, that is 1 over 2, 2 over 4, 1 over 2, 2 over 4, 1 over 2. So, your answer can either come in this form, or in this form. Generally, inverse of 2 by 2 matrix is usually in this form. 1 over the determinant, then you have A, B, D, A. So the negative of that guy. I hope you understand the determinant and the inverse of 2 by 2 matrices. If so, this is the question before us. It says this matrix is equals this matrix. What are we to look for? Find S. Find S. If this matrix is equal to this matrix, it means that the determinant of this matrix is also equals the determinant of this matrix. Anytime you are given two different matrices equation, and asked to look for an unknown, look for the determinant of the first one and equate it to the determinant of the second one. That would help you get the value of the unknown. This is a 2 by 2 matrix. The determinant of this guy will definitely be S times 1 or 1 times S minus 4S times 2. This should also be equals the determinant of the second matrix. And that will be minus 5 times 3 minus 4 times 3S. From here, this is S minus 8S is equals minus 15 minus 12S. If that makes sense to me, and if that makes sense to you. Collecting like terms, we should have something like S minus 8S plus 12S is equals minus 15. S minus 8S, that should give us minus 7S. Minus 7S plus 12S, that answer is not looking good, but you have S minus 8S, that is minus 7S, minus 7S plus 12S is the same thing as 12 minus 7, and that should give you 5. Yes, so 5S is equals minus 15. To get S, we divide both sides by 5. S is therefore equals minus 3. That is the value of S. Now look at this other question. This is as well under matrices equations. We are taught to find Y, and we are given this matrix multiplied by this to be equals this. And I told you that matrices are said to be equal if their corresponding elements are the same. And I told you to multiply two matrices, the number of columns of the first matrix should be equals the number of rows of the second matrix. Now look at this matrix. It has 2 columns, and look at the second matrices or the second matrix. It has 2 rows. So this guy and these guys can be multiplied. When you are given a matrix like this to be equals this will definitely lead to simultaneous equation for sure. But how do you arrive at the simultaneous equation? You use this matrix to multiply that and you equate it to the second matrix. This is it. You use each of the numbers here or values here to multiply each of the ones here. Look at this. You pick out 5. You say 5 times S. Then you say minus 6 times Y. Minus 6 times Y. This is equals 7. Also, you pick out these 2. You use them to multiply this guy. That will be 2 times S. 2 times S minus 7 times Y. Minus 7 times Y. This should be equals minus 11. So here equals this, here is equals this. With this, food is ready for you. 5 times s is 5s minus 6 times y, that is minus 6y. This is equals 7. 2 times s is 2s minus 7 times y, that is minus 7y. This is equals minus 11. If here were to be plus, it will simply be 5y plus, no, if this were to be plus, it will simply be 5 times s, 5s, plus 6 times y, plus 6y. It will equals 7. If this were to be plus, the equation would be 2 times s, 2s, plus 7 times y, plus 7y is equals minus 11. That is how you multiply matrices. From here, you solve and you get your value of s and you get your value for y. Solving this, you will get s equals 5, y is equals 3. We are not asked for the value of s, we are asked for the value of y. So, for example, it is 3. If you are given matrix like this and asked to add or subtract or multiply, this is what you should do. 1 plus 3. Then here, 2 plus 1. Then here, 3 plus 2. You see, you are the ones in similar position. For the second row, you have 2 plus minus 1. 2 plus minus 1. 3 plus 1. 4 plus 4. 3 plus 2. 1 plus 2. Minus 1 plus minus 6. Minus 6. So, no, minus 1 plus 6. Plus 6. If you solve this correctly, here will give you 4. You have 3 here. You have 5 here. You have 1 here. 2 plus minus 1 is 2 minus 1. You have 4 here. You have 5 here. You have 5 here. You have 3 here. And you have 5 here. You've added. If you are told to subtract or to find a minus b, instead of plus, you put minus. Minus, 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 minus. There is no difference in method of adding and subtracting matrices. It is just for you to understand the operation. Now, you can also be told to multiply these two matrices. If you are told to find a times b, this is what you do. Remember, I said to multiply matrices, you must first of all check whether the number of columns in the first matrix is equals the number of rows in the second matrix. Here we have 3 columns and here we have 3 rows. Multiplication shall we work. Then you distribute the rows over the column. You pick this first one, easy to multiply this. You pick the second one to multiply this. Pick the third one to multiply this. Then you take this second one, distribute it over the second column. So, this is how to multiply 3 by 3 matrices. 1 times 3. This is okay. You take the next one, 2 times minus 1. 2 times minus 1. You pick the third one, 3 times 2. You are done with the first row. You take the second one, you distribute it over the second column. 2 times 1, 2 times 1. 3 times 1, 3 times 1. 4 times 2, 4 times 2. You are done. Then you pick here the third one, distribute it over the third here to have 3 times 2, 3 times 2, 1 times 4, 1 times 4, minus 1 times 6, minus 1 times 6. That is it. You've multiplied the matrices. For this matrix, this is 3 by 2 matrix. And this is 2 by 3 matrix. Is multiplication possible? Yes, if and only if the number of columns here is equals the number of rows here. Here we have 2 columns, here we have 2 rows, so multiplication is possible. Now, how do we multiply? You simply distribute one over another. You take these 2, you distribute it over here. You pick these 2, you distribute it over here. You pick these 2, you use it to multiply here. To have 3 times 4, 2 times 5. You are done. This is only here. Then you move to the next one. 4 times 3. 1 times 1. You move to the third one. 5 times minus 2. Minus 1 times 4. That is it. So, multiplying 3 by 2 matrices with 2 by 3 matrix, you notice that the result is a 3 by 2 matrix. Here we give you 12, 10, 12, 1, minus 10, and minus 4. That is your answer. Now look at here. This is a 2 by 3 matrix. This is a 3 by 1 matrix, a column matrix. Is multiplication possible? Yes, because here we have 3 columns and here we have 3 rows. If the number of columns in the first one is equals the number of rows in the second one, multiplication is very, very possible. And how do we multiply? This first row, you use it to multiply the column. This second row, you also use it to multiply the column. That is basically what is going to happen. 3 times 7, 0 times 4, 8 times 5, and 1 times 7, 0 times 4, and 2 times 5. This will give you 21, 0, 5, 10, 15, 20, 25, 30, 35, 40. 40, 7, 0, and 10. If I am correct, that will be the result of this matrices multiplication. Now, if you are given a matrix like this and asked to look for the value of S, since everything here is equals 15, it means the determinant of this matrix is equals 15. Find the determinant of this guy and equate it to 15. This will give you like this. 7 times S is 7S plus minus 2 times 3, 6. This is equals 15. 7S is equals 15 plus 6. 7S is equals 21. S is equals 21 over 7. And that should give you 3. This is the value of S. If you actually put 3 here and find the determinant, it will be equals 15. Another way question can come under matrices is that you'll be given a 2 by 2 matrix like this. You'll be asked to look for the value of k squared plus k plus 1. K squared is simply k times k. So 2, 1, 3, 4 times 2, 1, 3, 4. This is k squared, k times k. Then plus k is the same matrix, 2, 3, 1, 4. Then plus, this is not 1, this is actually unit matrix, because in dealing with matrices, addition or subtraction, they must have the same number of rows and the same number of columns. The identity matrix I for 2 by 2 matrix is something like this: 1, 0, 0, 1. So if you are given I, it is the same thing as 1, 0, 0, 1. Don't forget this. This is the identity matrix. And remember, when you operate a number with the identity, you get the number binary operation. From here, you simply multiply these matrices. Your answer, add it to the two other matrices. You get what you are looking for. Then if you are given something like this and they say find this guy, P, it means find the determinant. JAMB will not ask you for the inverse of 3x3 matrices. The first step to find determinant of 3x3 matrices is come here, put plus here, put minus here, put plus here. Are you done with that? Yes. Do like this, and do like this. First thing, pick out plus 1 to have plus 1. After writing plus 1, write the matrix sign like this. This is what we are dealing with, right? Do something like this. And do something like this. Along the one we are dealing with, like this and like this. Doing that, what will remain? We'll be left with 4, 0, 5, and 1. Close it. Now, pick the second one, which is minus 0. Minus 0. Draw the matrix box like this. In this minus 0, do something like this. Then since we are dealing with here, you do something like this. Now that you've done this and this, what is remaining that is not crossed? It is 3 minus 1, 5, and 1. Here, we are dealing with plus minus 1. So that is plus minus 1. You do something like this. It's like this now. What is remaining? Here and here already crossed. 3 minus 1, 4 and 0 are remaining. 3 minus 1, 4 and 0. This is the essence. Anyone you are dealing with, ignore the values that are in the same row and column with it. If you are dealing with 1, the ones that are in the same row and column with 1, ignore them. Write out the remaining. If you are dealing with row 2, no, row 1, column 2, ignore these numbers that are under the column and ignore the number that they are in the same row. You have this remaining. Dealing with the third one, ignore the ones that are in the same column, ignore the ones that are in the same row. Write out the others. This is a way of converting 3x3 matrices to 2x2 matrices to make life easier for us. If it were 4x4 matrices, you do plus minus plus minus. Then with that, be able to convert all of them to 3x3 matrices. From there, you convert 3x3 matrices to 2x2 matrices. Then you solve. But that is beyond the scope of this class. This is plus 1. The determinant of this guy is 1 times 4, 4, minus 0 times 5, 0, minus 0. 1 times 3 is 3, minus 1 times 5, that is minus 5, minus 5, that is plus 5. For the sake of JAMB, this is already 0. Everything here will definitely change to 0. We wipe. So for the sake of JAMB, you can actually skip this step and say plus times minus 1 is minus 1. And 0 times 3 is 0, minus 1 times 4 is minus 4. 0 minus 4, that is 0 plus 4. This will simply be plus 1, 4 minus 0 is 4, minus 1, 0 plus 4 is 4. This is 1 times 4, 4, minus 1. Everything here is actually 0. That is what I got. Let's see if I am correct, and let's see if 0 is in the option. 0 is in the option, so option B is the correct option. If this 3x3 matrix is equals 132. Find the value of S. Just like we did for 2 by 2 matrices, in 3 by 3 matrices, if one is equals the other, what you simply do is this. Find the determinant of this and equate it to 132. And to find the determinant of this guy, we start with plus, minus, plus. We bring out plus 2, then like this, like this, like this. What is left is 1, 3, 4, 2. We pick out minus minus 5. This minus must be there. You write out the minus. Then here is minus 5. You add the minus 5. So don't say only one minus. No. This minus must already be there. And this value here is minus 5. So once you cross here like this also, for here and here, what is left is S 0, 4, 2. Since we ignore the column and the row, then we are in plus 3. Plus 3. Under this plus 3, we ignore this column, ignore the row that it is. We are left with S 0, 1, 3. This is equals 132. If I am correct, plus 2 will mean 2 times 1 is 2 minus 3 times 4, 12. That is the determinant of this guy. Minus times minus is plus. So plus 5. 2 times S is 2S minus 0 times 4, 0. Plus 3. 3 times S is 3S minus 0 times 1, 0. This is 132. 12 minus 2 minus 12, that is minus 10, times 2 minus 20 plus 2S minus 0. Yes, already 2S times 5, 10S plus 9S is equals 132. Collecting like terms, 19S is equals 152. Yes, because 132 plus 20 is 152. S is equals 152 divided by 19. 152 divided by 19 seems impossible. Ladies and gentlemen, to the best of my surprise, to the best of my shock, this is equals 8. If you want to confirm, multiply 8 by 19, you will get 152. Thanks for watching. Your one and only teacher from the future. I hope you found this class interesting. Feel free to check out the playlist for more amazing videos. And don't fail to install the Flash Learners application right now for notes, videos, and questions to meet all your needs. Subscribe to this channel so you don't miss out any of my sweet videos. See you in the next episode. Don't forget to tell everyone around about the Flash Learners. Bye.